today, 20th March.
Sir, World Happiness Day.
Yeah, may I know who answered?
Sir, Deepthi.
Deepthi Nawal.
Yes, sir.
What is the day today? Tell me. What is the
Sir,
significance of today?
World Happiness Day.
Okay. There are many significances today, but something is of importance to us. One is 20th March is the equinox day when the spring session starts as per the weather report. Sun will be exactly on the equator today. The north hemisphere and the south hemisphere now have different seasons starting. That is why it is known as the equinox. Sometimes it's on 20th June, sometimes it is on 21st June, depending upon leap year, etc. It's not fixed. But this year it is on 20th of March 2021. Next, it is also World Sparrow Day. हम तो बचपन में बहुत कहानी सुने कि चिड़िया वो चिड़िया कहानी चिड़िया राइम्स एंड ऑल बट आजकल चिड़िया ही नहीं है सब तो गायब हो गए हैं we all build multi-storied complexes in which there is no place for chidiya, right? So the world celebrates 20th March every year as World Sparrow Day also to remember the sparrows, small bird. Okay, they are very old. They are there, surviving still. Third is something very nice, International Day of Happiness. आज विश्व खुशियों की दिन है, right? 20th March is International Day of Happiness. Remember, all countries, you have studied in economic study, GDP, GNP, gross national product, etc. Bhutan was the only country which said that ये सब में क्या फर्क है? And they introduced a term called GNH, gross national happiness. What matters to a country is how happy people are, not how rich the country is. Right? It's a very profound statement. So, United Nations has declared every year 20th March as International Day of Happiness. So, wishing you all a happy day. Many people think to be happy, one must be rich, one must be successful. I want to tell you that you need not be rich or you need not be successful. My own example, I am not rich. I'm just an ordinary professor. Right? If I am rich, I am more worried where to keep the money, hide it, black money, tax, raid, ये सब चिंता ही नहीं है अभी रेड में आओ कुछ नहीं मिलेगा केमिकल टेक्नोलॉजी नोट मिलेगा घर में ओके और केमिकल प्रोसेस कैलकुलेशन का आंसर पेपर असाइनमेंट मिलेगा ओके सो यू नीड नॉट बी रिच टू बी हैप्पी right? So to be rich and being happy or not, there are many people very poor on the roadside, they are very happy, right? So degree of happiness has nothing to do with your bank balance, so keep that in mind, right? And second thing is successful people, they say that are happy people, but remember, to be successful you must be happy. If you are not happy, you will not be successful, right? Because if you are dukhi money, you start doing things, you will goof it up and gaya. Okay, Priya Chaudhary, spelling mistakes, resume. Instead of five-fold learning, you write, somebody write, I have 5 food training in Banastali, etc. Okay, so to be successful, you need to be happy. So be happy and be successful. Okay, so don't bother about being rich or something, and you should have enough to live your life. Okay, that's it. And thank you all. Let's get going with today's class, and we are on a new topic: pulp and paper. The virtual education has almost put an end to pulp and paper. You don't read textbooks. You don't write exams in answer paper. Paper bach gaya, but paper to rahega. Right? Syllabus mein pulp and paper is there. Okay. So let's see. Where are we now? Okay, so there it is, and let's see. Okay, are you able to see the slides?
Yes, sir.
Okay, so I'm just changing, please confirm. Changing.
Yes, sir.
You are seeing the change, very good. Over to the show. Yes. Welcome to Department of Chemical Engineering, Banastali Vidyapeeth. We are on CHC 305 Chemical Technology, lecture number 30. See, we have seen hydrogen, inorganic industries, fertilizers, phosphoric acid, chloralkali industries, cement, uh, coal technologies. Now, then we moved into coal technologies, petroleum, upstream, downstream, petrochemicals. Now it's time for us to get on to a new topic, pulp and paper. Right. Remember, the per capita consumption of paper denotes how literate a country is. And is a very important economic parameter. What is the per capita consumption of paper in India? Somebody can compare, the paper consumption, say, in United States and India. They are far behind. You know, the New York Times of Sunday will be about 100-page newspaper. I don't think in India there is any newspaper which is 100 pages. Okay, so there's a big difference in the paper consumption between countries like USA and India. Okay, I leave the per capita consumption for somebody to find out and share it. But we get going. We are pretty low on the per capita consumption of paper, and paper is made up of cellulose, and the raw material for cellulose comes from wood. Okay, so it's and trees are renewable. I cut a tree, I plant a tree, so the sort of renewable resource for me. And you have here the typical structure of the tree. Everyone knows, it's not my drawing, but to quickly give you an idea of the parts of the tree, I'm putting it that, see, the one below the ground level, is all roots. This is a root system. All right, what is below the ground? And this part, this crown-like thing, this is known as a crown. This is like mukut for the tree. The leaf and the structure, I mean, don't count this one. So there is root here, and I'm just mark the cursor. So it goes like this, goes like this, goes like this, goes like this, goes, and completes down. This is known as the crown. As if you put and a mukut on top of the tree. And this is the trunk. So you have the root system, the trunk system, and the crown. Crown contains all the leaves, branches, flowers, and everything that happens. Right? So this is the crown, this is the root system, and the crown and the root are connected by the trunk. Okay, so then, see, the trunk has got a bark. Every tree has got a thick skin. That is a bark. That is like a protection for the tree also. And the inner layer of the bark is what? See, the carbohydrates are distributed through the, what is this, inner bark. So the inside layer of the bark is what, takes the carbohydrates into all parts of the tree. And see, the trunk has got a sap. When you cut a tree, it is sticky. That is known as the sap of the tree. So the water is transported to all parts of the tree by the what is this sap. And this carbium, this is cambium, I'm sorry, this word is cambium. See, in a tree, the bottom trunk doesn't grow. Just the portion slightly above the root, right? That is the bottom trunk. that doesn't grow. That, maybe become fatter, but it doesn't grow. But the portion above this is what is growing. Every year it adds height and the tree becomes taller and taller. So the growing part of the trunk is known as cambium. Okay, the growing part of the trunk is known as cambium. And, the tree is the wood. Wood is nothing but cellulose, and that's what we are interested in. Okay, so this is about the structure of the tree. Wood is an important raw material and one of the few renewable natural resources. Yeah, I'm calling it renewable because I plant a new seed, a new tree comes, so it is renewable, right? The engineering properties exhibited by wood have confirmed the suitability as a construction material for range of end use. You know that earlier houses were built, with wood only, right? So wooden pillars and wooden roof, etc. Then wood is also the basic raw material for the paper making industry. It is used also in the textile industry. Remember, wood has got cellulose, and cellulose is what is used for making the pulp that from which paper is made, and the cellulose pulp is also used in the textile industry for making fibers. That's known as rayon. We'll come to it later. So you can see that the wood pulp is an input for both the paper plant as well as for the textile plant, which makes viscose rayon, grasim nagda, and is also used in the manufacture of wood composites and panel product for the building industry. So today you see, wooden boards come partition between the room, right? These are known as panel products, right? So they are all there, more uses of wood. But primary uses are for paper making, and the wood is made into a pulp, that is cellulose pulp, and the cellulose pulp may be used for making paper or for making viscose rayon fibers in the textile industry. Quick chemistry of wood, chemical composition of wood. Wood has carbohydrate 75%, lignin 20 to 30%, extractives 5 to 10%, some inorganic material, ash, that is about 0.5%. This uh, ash content varies depending upon the tree, whether it is in the tropical part of the earth or in the temperate zones of the earth. India, etc., are in the tropics, and the temperate zones will be, say, Europe and Arctic, etc. Right? So, temperate zone, the ash content is low, 0.5, whereas in the tropics it is more, 1 to 5%. So mainly it is, remember, carbohydrates and lignin. Extractives are there not in all trees, in some trees, right? So see, some trees have oil content from which useful oil may be extracted, right? But not all trees are like that. But all trees, carbohydrates and lignin, this is the major one. Carbohydrates is 75%, lignin is 20 to 30%. Now, these carbohydrates are nothing but polysaccharides, and they are collectively known as holocellulose. Right? So, carbohydrates or polysaccharides are also holocellulose is 75%. Now, holocellulose is made up of cellulose and hemicellulose. Wow. Cellulose and hemicellulose. Remember, cellulose plus hemicellulose is known as holocellulose. And there is also some starch, some pectin substances, and some water-soluble polysaccharides like arabinogalactons, etc. These are sugars of a different kind. Right? So this is a brief composition of wood. Now you look at this. Cellulose and hemicellulose. Cellulose and hemicellulose are the two types of polymers that serve as structural component of the plant cell wall. Right? So the plant cell wall. Both of them are polysaccharides. Yes, they are polysaccharides. Cellulose and hemicellulose, collectively known as holocellulose. Thus, both cellulose and hemicellulose are made up of sugar monomers. So, basically, you can see that this cellulose and hemicellulose are polymers of various sugars, right? Sugar monomers. And cellulose is produced by the polymerization of exclusively beta glucose monomers. Cellulose is a polymer which is made up of beta glucose. Glucose is a sugar, right? So beta glucose is a monomer, and the polymer from beta glucose is what is called cellulose. And what about hemicellulose? In contrast, hemicellulose is made up of several monomers. See, the one with glucose is known as cellulose. All other sugars, the polymers are known as hemicellulose, right? Xylose, like glucose, xylose is a sugar. Galactose, mannose, rhamnose, arabinose, these are all different sugars like glucose, right? And polymers of xylose, galactose, mannose, rhamnose, arabinose, they are all known as hemicellulose, while the polymer of glucose has a special name, cellulose. Cellulose is a long polymer, while hemicellulose is short, right? So long polymer and hemicellulose is short. And another difference is cellulose is a straight chain polymer. It's not only long, but it is also a straight chain. And hemicellulose is cross-linked polymer. Cross-linking means, like a spider web, right? This is like a straight chain polymer. And cross-linked polymers, they have different physical properties. And straight chain polymers will be useful, say, for certain application, whereas cross-linked polymers may not be useful. Of course, we have put the composition of wood again for a quick review. This wood cell wall component has lignin and polysaccharide. This is the cell wall, and the bark, etc., contain materials which are partly or wholly insoluble in solvent, partly soluble in solvent, and you get resin, fatty materials, alcohol, and phenolic substances. And those who are insoluble may be mineral constituent, proteinaceous matter, and pectic substances. This is typically from the bark of the tree. This is inside the bark, the cells, right? The tree inside. And you see the polysaccharides, they are both cellulose and hemicellulose. Cellulose and hemicellulose is what is known as the holocellulose, right? Recollect this. Cellulose plus hemicellulose is holocellulose. And cellulose is made up of D-glucose, that is the beta glucose, right? And hemicellulose may be made up of pentose, hexose, uronic acid, acetic acid. Pentose means 5 carbon sugar, xylose, arabinose. Hexose means 6 carbon sugar. D-glucose and D-mannose and D-galactose. Uronic acid is uronic acid and methoxyuronic acid, acetic acid. I mean, this is the only special glucose monomer for cellulose. Of course, in cellulose, you also have alpha cellulose, beta cellulose, gamma cellulose. What is this? Alpha cellulose has a degree of polymerization 1000 to 3000. We'll be learning about degree of polymerization soon, but polymer is made up of many monomers. So the number of monomers in a polymer is what is known as degree of polymerization. That means when you say 1000 is a degree of polymerization, it means 1000 monomers have combined to form this polymer. That is degree of polymerization, right? So alpha cellulose has a high degree of polymerization. Beta cellulose 10 to 100. Gamma cellulose is less than 10. Now, for certain purposes, we need alpha cellulose only, right? Some of them may not be useful. So, especially when we come to the next topic on viscose rayon, we will know more about alpha, beta, gamma cellulose. Okay, so keep in mind, alpha cellulose has a high degree of polymerization, beta cellulose is low 10 to 100, gamma cellulose is pretty low 10, less than 10. Now, preparation of wood pulp. Now, first let's know what is pulp. Pulp is a commercial fibrous material obtained from bamboo. Instead of wood, the raw material may be bamboo. Remember, bamboo is not a tree. Bamboo is a grass. Learn, right? Bamboo is not a tree. Many people think it is bamboo tree. No, bamboo is a grass, right? And wood Of course, all trees wood. Bagasse, this is that waste from sugarcane. You remember the sugarcane juice wala? He puts the sugarcane into the rollers, and the juice is extracted, and the remaining material which he throws out is known as bagasse, and that is also nothing but cellulose. Okay, so pulp is a commercial fibrous material which may be obtained from bamboo or wood or bagasse. Bagasse is a waste material from sugarcane crushing, maybe by mechanical and chemical means. Right. So let's say I apply mechanical methods and chemical methods, I can convert bamboo, wood, or bagasse into a pulpy material. Pulping means disintegration of bulky fibrous material to small fibers. Breaking, see, remember when the bagasse is, treated, you will find it is separating into fibers, right? So, I want to remove the lignin. Remember, we said that no, 20 to 30% in lignin. Lignin is a dark colored aromatic substance which is of uh, only value more as a fuel and for some special chemicals, but for paper making and for textile making, lignin is simple no, 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 not wanted. Okay, so basically, we want to get rid of the lignin. So the main objective of pulping is to remove the lignin and put the cellulose in a pulpy way, fibrous material. The three methods for producing the pulp: mechanical, chemical, semi-chemical. Mechanical means purely by mechanical action. You see, if I have, let's say, wood, and I soften the wood by what you call soaked in water, and then start crushing it, right? So the fiber breaks, and you end up with a fibrous material, right? And that is mechanical pulp. Usually, mechanical pulp does not have much strength because you have not actually removed the lignin. You have only crushed broken the cell wall and reduced it to a pulpy matter. But the lignin, etc., has not been removed. So, mechanical pulping does not remove the lignin. So, it will not be of a very quality. The paper made by mechanical pulp will not be a very good quality for paper making, and definitely it's not going to be useful for making fiber also. But mechanical pulp is easy to make only by applying mechanical force. I am converting the wood into pulp, and I use the mechanical pulp for certain applications like newspaper. Right, newspaper doesn't need much strength and shelf life. You don't keep the newspaper for lifelong. After about 1 hour, when the newspaper comes, it has already become a waste paper, right? So you chuck it. So it doesn't need much, quality. It needs just a paper to print something, and mechanical pulp is good enough to do that. But of course, you want a good print, etc. The newsprint. What is newsprint is the pulp that is used for newspaper making. That contains a large quantity of mechanical pulp, and of course, some mixing of the other pulps are also done, to improve the look and printability. Remember, some newspapers are very yellowish in color, right? And some newspapers are very bright white. That is because, they have blended various pulps, to make the paper. So, mechanical pulp. Chemical pulp means I add certain chemicals to the wood so that my lignin is dissolved and my cellulose, etc., separates out. So, by the addition of chemicals is chemical pulping. The next one is semi-chemical. Semi-chemical is it uses partly mechanical and partly chemical. See, the mechanical method may also use steam, right? Suppose, I have a bag full of wood chips and I keep passing steam over it, right? So, steam will break the walls of the wood, and resulting will be a pulp. So, you may also call mechanical pulp. Doesn't mean you need some crushers to break it into pulp, but it can also be done with steam. So that's the application of heat. So that is known as thermomechanical pulping. Applying heat and mechanical force to make the pulp is thermomechanical pulping. Right. So the semi-chemical method is a combination of mechanical, thermal, and chemical methods. That is semi-chemical. Right. Only by applying chemicals is chemical. By applying heat and mechanical force is mechanical. A combination is semi-chemical. Of these three, the chemical methods may use what do you call various alkaline materials, right? Because the alkalis attack the lignin, etc. So, out of the chemical pulping, kraft, K-R-A-F-T, this is a Swedish word. Kraft means strong. Kraft is a Swedish word which means strong. The kraft pulping process, also called the sulfate process. Remember, when you say kraft pulping or sulfate process, it means the same, most popularly used process. So that's what we are going to go into. This is an alkaline process, meaning, you see, some pulp has been made by just by addition of caustic soda, but there are other pulping methods that is known as caustic pulp only by caustic soda addition. But the other methods use chemicals also. The main cooking chemicals are sodium sulfide Na2S and caustic soda NaOH. So a mixture of sodium sulfide and caustic soda is what is known as the cooking chemical. The wood chips will be cooked, right, by adding sodium sulfide and caustic soda. The presence of sodium sulfide makes the bleaching of pulp easier. Remember, you want the pulp to be bright so that the paper looks white. Remember, when you, some notebooks are pale yellow papers, some notebooks are very bright white papers. So that is all because of the type of pulp that has been made and the bleaching that has been done to the pulp to bring the degree of whiteness. Okay, so just come on it like the sodium sulfide make the bleaching of pulp easier so that the brightness comes and the paper produces better strength, right? So craft process, I already told you, craft means strong in Swedish, right? So it is produces sulfate, also called sulfate process. So the cooking chemicals, keep in mind sodium sulfide and caustic soda, right? So, but why is it called sulfate process? I am using sodium sulfide and caustic soda, but I am calling it sulfate process. Right? So we will answer this question shortly, but keep the question in your head. Now we will have a diagram to study the craft process, right? So the chips, remember you can't put a tree, and add chemicals to it. So the tree must be debarked first, right? Because the bark, is a very dark and thick substance and it doesn't have any fibrous material. So the first job is from the tree, debarking is done. So the barks are just shaved off and then the wood is cut into chips. Remember, for the chemical to act, you need to make the wood into small chips, right? And it is put into digester. And I add what is known as white liquor. This white liquor is nothing but a solution of sodium sulfide and caustic soda. Remember, this white liquor is sodium sulfide and caustic soda. See, don't try to look at the figure on all sides. Go in the same order in which I am covering. So the debarked wood is made into chips and the chips are put into digester with white liquor added, and white liquor is nothing but a mixture of sodium sulfide and caustic soda. Now, the digestion cooking, the wood is cooked in this chemical and is under high pressure, and the pressure is released, that is known as blow tank, and from there it goes into washers where water wash is done, and after washing I get a pulp, and this pulp goes for bleaching, right? So what happens to when you wash, you get a solid material, fibrous material, that is a pulp which goes for bleaching. That keep that in mind. Now what happens to the other side? So when you wash the pulp, you get the output which is known as weak black liquor. Why it is black? Because a lignin, what is there? Lignin in wood has all been captured by the chemicals and comes out as a weak black liquor, right? So some of the chemicals, sodium sulfide, caustic soda, and dissolved lignin, they all come out as weak black liquor. Then it goes into evaporators. All right, because this weak black liquor is quite dilute and it must be concentrated. Usually the concentration is done by multiple effect evaporators. Please, keep in mind it is not evaporator, it is multiple effect evaporators. So there are multiple stages in which the evaporation is done, and so the weak black liquor becomes strong black liquor, right? So from strong black liquor, please use the word liquor here doesn't mean the alcoholic beverage. The word liquor here means the chemical solution. Okay, so don't get carried away. So the weak black liquor becomes strong black liquor, which goes to a recovering furnace. Why it does going to a recovering furnace? Right, because the black liquor contains quite a bit of the chemical sodium sulfide and caustic soda, and I have to recover it. Right. So the chemicals I want to reuse. Right. So I want to recover it. So the black liquor is put into a furnace and burnt. Why it will burn? Black liquor itself, it's only made up of lignin, etc. It's the only carbohydrates, hydrocarbon. So it simply burned. And in the recovery furnace, I will be adding, it's not shown in the figure, but just capture what I am talking. Into the recovery furnace, one input is a black liquor and the other input is sodium sulfate, Na2SO4, right? And sodium sulfate is added into the recovery furnace. Not shown in the figure, but keep it in mind, sodium sulfate. Now, because we add sodium sulfate, this process is known as sulfate process. And this addition of sulfate is very crucial for the recovery of these chemicals, right? Recovering sodium sulfide and caustic soda, the white liquor to be generated back, the addition of sodium sulfate is very crucial. And in the black liquor and sodium sulfate, the furnace produces an output which is goes into a dissolving tank, and the output is green liquor, and the green liquor goes to a slaker. What is the slaker? Slaker is nothing but calcium hydroxide, right? And then it goes to causticizer, and from there the liquid is white liquor. White liquor goes again into the system. So remember, white liquor input, it comes out as weak black liquor, then it becomes strong black liquor, and then it becomes green liquor, and then again it becomes white liquor, and the circuit is complete. Okay, so how do I get this line? Calcium oxide, calcium hydroxide. I burn calcium carbonate in a kiln. So, on calcium carbonate on heating gives you calcium oxide and carbon dioxide. So the calcium oxide with water will become calcium hydroxide, and the causticization takes place. We will come to the reactions now. Okay, so this is the flow sheet of the process. What are the reactions that are happening? So I'm putting, lignin as R dash. R could be any hydro, CH3, C2, H5, etc. R dash could be any other combination. We are generalizing. R dash with caustic soda become RCOONA and ROH. And R dash Na2, sodium sulfate, you get what are known as mercaptons, right? So basically, the sodium sulfide and caustic soda is combining with the lignin. R dash R is the generalization of the lignin formula, and I get these output. And the chemical recovery from black liquor is which is rich in lignin. Black liquor first goes through multiple effect evaporators. This is what I told you. Should be written as multiple effect evaporators, which concentrate the black liquor from 15 to 18% solid to 60 to 65% solid. So the weak black liquor contains only 15 to 18% of solid, whereas the strong black liquor after multiple effect evaporation contains 60 to 65% solid. Okay, then smelting is done. Now what happens? You see, remember, we formed, some sodium salt, NaR, right? So NaR with air becomes sodium carbonate and carbon dioxide. Sodium sulfate combines with carbon. Carbon is formed due to side reactions in the furnace. It forms sodium sulfide. Wow, remember, sodium sulfide was one of the components of the white liquor. So I have sort of regenerated my sodium sulfide. So the carbon came because the lignin, when it burned, some side reactions produce carbon, and the carbon combines with sodium sulfate to form sodium sulfide, which is what is the part of my white liquor, right? And what else? This sodium carbonate. But remember, our chemical is sodium hydroxide, not sodium carbonate. So the sodium sulfide and sodium carbonate go to causticizing. What is causticizing? The sodium carbonate is reacted with calcium hydroxide. It forms caustic soda and calcium carbonate. Right, and calcium carbonate on heating gives you calcium oxide and carbon dioxide. Calcium oxide plus water gives you calcium hydroxide. So this part is also a closed loop, right? I get here calcium. I get here, what is this? Calcium carbonate, right? The calcium carbonate goes into the kiln and forms calcium oxide and carbon dioxide. Calcium oxide with water forms calcium hydroxide, and calcium hydroxide with NaOH forms calcium carbonate, right? Sorry, sodium carbonate and calcium hydroxide, they form caustic soda and calcium carbonate. Where did the sodium carbonate come? In the furnace, the lignin burnt with air to produce sodium carbonate. And the sodium carbonate is combining with calcium hydroxide to form caustic soda, which is part of the white liquor. Remember, white liquor has Na2S and NaOH. Both have been regenerated. And this is the beauty of the craft process. And recovery is a very crucial thing. So sodium sulfate is added. Sodium sulfate is added to regenerate the sodium sulfate. That is why this process is known as sulfate process. Now you know, I asked you why is it called sulfate process? You have now the answer. Okay. So now we'll have a look at it. Chipper bin. All right. So remember that this figure we are explaining now. Chipper bin. Chips are fed in this device. Cut logs are conveyed to the chipper where rotary discs with heavy knives reduce the wood to 2 to 5 centimeter flat chips. Size reduction is done to maximize the penetration of processed chemical. Remember, if the chip size is small, the chemical has ample scope to act on it. If the chips are large, then the surface area is not much, so only the wood may not be fully digested. Then the digester tar. Remember, this digester tar is a huge, it's not just some small, pressure cooker or something. The digester tar is a tall column, right? 25 to 30 meters tall, right? 25 to 30 meters means, clean 4 to 5 Amitabh Bachchan standing one above the other, right? Chips are preheated with volatilizing turpentine and non-condensable gases. See, some of the chips may contain, oily material which has to be removed for controlling the digestion temperature. Cooking liquor is withdrawn as side stream and circulated through heat exchanger. Digestion is done to free the lignin and other non-cellulosic content. Cooking is about 1.5 hours at 170 degrees C to avoid mechanical weakening of fibers. The digested chips are cooled with recycled black liquor and temperature is maintained 140 to 180 and pressure is 10 atmosphere. So the digester is at about 170 degrees centigrade, and about what is the pressure? We just saw 10 atmosphere pressure. The bottom temperature is, at 65 degrees. The top temperature is 140 to 180. That is the top of the digester is 140 to 180. The bottom is 65. Blow down valve, right? Go to the figure, blow down valve, blow tank, right? So here the valve reduces the pressure of the stream from 80 atmosphere to 1 atmosphere. Remember, I think this pressure is more, not 10, it will be about 80 atmosphere, right? So the pressure is reduced from 80 to 1 atmosphere before entering the blow tank. Blow tank is when hot pulp slurry is passed to the blow tank, heat is recovered in the form of steam. So the blow tank, some water is converted into steam, and the chips are preheated with this recovered steam, right? See, by preheating the chips, you are making it softer so that the cooking is effective, right? So I am generating steam at the end of the digester, and I will use the steam to cook the chips before they enter the digester. The blow tank has a high concentration of pulp and low concentration of water. Then there are screen. Pulp is screened so as to remove the wood knot and undigested residues. Series of filters. Pulp is filtered to separate the black liquor for chemical recovery plant, and the black liquor is recycled back to the digester for cooling the digested chips. Right. And hot water is added to the second filter for better filtration. Bleaching of pulp. Why do we need bleaching of pulp? See, the pulp that is produced from the digester is a little dull yellow in color, and it is strong. The craft process gives you strong pulp, but not white pulp, right? But I need white paper, so I need to bleach this pulp. So bleaching may be done. To produce white paper, the pulp is bleached. The chemicals used to bleach pulp must be environment friendly, obvious. Bleaching with chlorine produces. Earlier, most of the plants used to do the bleaching with chlorine, and chlorine produces a whole lot of dioxins and other undesirable products which are harmful. So people have now switched over from chlorine, and pulp is bleached with hydrogen peroxide, ozone, chlorine dioxide, oxygen, etc. The objective of bleaching is to remove small, why is the color? Some lignin has got carried away in the pulp, right? It has not got fully digested. So we are removing the lignin which is carried away in the pulp by bleaching, right? So I may use hydrogen peroxide, ozone, chlorine dioxide, oxygen. Originally used chlorine, which is phased out now. Bleaching chemicals also include chlorine. In short, it is known as C. Chlorine dioxide abbreviation is D. Alkaline extraction, like caustic soda, it is E. Hydrogen peroxide, symbol is P. Sodium hypochlorite is H. Ozone is Z. Right? These are symbol C, D, E, P, H, Z. Now, classical bleaching sequences are CEH. CEH means C stands for chlorine, E stands for extraction, and H stands for hypochlorite. So one bleaching may not be enough. You may have to do multiple series of bleaching depending upon the wood pulp. So some of the bleaching sequences are CEH, CEHH, CEHEH, CEHHD, CEHJH, CEDD, CEHGD, CEDH. See, remember, choosing the bleaching sequence will depend upon the type of wood that is chosen and the quality of the pulp that is got, right? That will determine the degree of bleaching and the sequence of bleaching. Now we have some thought-provoking questions. Wow. Why is the blow-down valve introduced in the flow process? Answer, it reduces the pressure of the pulp from 80 atmosphere to 1 atmosphere before entering the blow tank. So the digester is at about 80 atmospheres, and I have to reduce the pressure. That is why the blow down valve is kept. Why is hot water added to the second filter and then spent water is circulated to the first filter? This become hot water has maximum efficiency to remove the dissolved chemicals from the bleach pulp. Therefore, the hot water is used in the second filter. Remember, there's a series of filters in which the pulp is filtered, right? So the spent water can remove maximum solid from the pulp. The operation is counter current. That's why hot water is added in the second filter, and then the spent one is circulated to the first one. What is the technical difference between sulfate process and sulfite process? Sulfate process is an alkaline process, whereas the sulfite process is an acidic process. This is chemical pulping. Although the sulfate process is the most popular, there is also an acidic process which is known as sulfite, F-I-T-E, right? The pulp has to be bleached more in the sulfate process as compared to the sulfite process. So in the acidic process, what happens is the pulp is bright in color, but not strong, right? But the sulfate process, the pulp is strong, but not white, bright in color. Both are counter. Sulfite process produces bright pulp, but weak pulp. Sulfate process produces strong pulp, but not white pulp, right? The pulp has to be bleached more in the sulfate process as compared to sulfite process. For sulfate process, digestion time is 2 to 5 hours at temperature 170 to 180 or 176 and pressure 660 to 925 kPa, whereas in the sulfite process, time required is 6 to 12 more hours. So this acidic process requires more time for pulping. Temperatures are low, 125 to 160. Pressure is comparable, 620 to 750, but on the lower side. Raw materials are less significant and fibers have better strength properties than sulfate process. Why is the black liquor entering at various sections of the digester? See, some part of the black liquor is, recycled back to the digester because for the cooling and the temperature control of the digester. Remember, the digester requires a temperature control. So to do that, some black liquor is recirculated back to the digester for this thing, and also it avoids mechanical weakening of the fibers. It withdrawn a side stream from the digester and circulated through a heat exchanger to reheat and control the digester temperature. It is also used along with white liquor to adjust the solid liquid ratio in the digester, the entry section. Thereby, desired operating conditions of the digester is met. How is turpentine recovered in the pulp manufacturing process? Turpentine is obtained by the distillation of resin obtained in the pulp manufacturing process. Remember, the chip, the bark and all you cut, from there some oil can be extracted. That is how this comes into picture. What are the other byproducts of the pulp and paper industry? Main byproducts are turpentine, rosin and tall oil for making soap, etc. Right? But these may not be coming from all trees. Only some trees have oily substances from which oil can be extracted. What is sulfidity? This is different. The mass ratio of sodium sulfide to caustic soda plus sodium sulfide. So, how much is the mass ratio of sodium sulfide to caustic soda plus sodium sulfide? This is known as sulfidity, where all masses are expressed on Na2O basis. This is known as sulfidity. The presence of sodium sulfide makes the bleachability of pulp easier and paper produces better strength properties. So, the sulfidity is the quality of the white liquor. And what is solvent pulping? In solvent pulping, lignocellulosic feedstock is contacted with organic solvents such as acetone, methanol, ethanol, butanol, ethylene glycol, formic acid or acetic acid at 140 to 220 degrees C in an aqueous solution which has 20 to 60% water. Right? I may use whole lot of solvents also to do the job. Right? Remember, my aim is to remove the lignin. If instead of chemicals, some solvent can pick up the lignin, well and good. Right? So that's known as solvent pulping, but that is also a chemical pulping. Right? Subsequent separation and recovery of the solvent is carried out using distillation. Ethanol is preferred solvent for solvent pulping. Solvent pulping produces 4 to 5% higher yield than crack pulping. Okay. production of paper. Now that the pulp is made and you have bleached it to the required degree of brightness, now comes the paper making. Paper is a sheet material made up of fibers which are held together by hydrogen bond. Remember, you just put your soak the paper in a bucket of water, you will see that water has penetrated through it and the paper has been reduced to a pulpy material, right? So paper is held, by the hydrogen bond, and when it dissolves, these hydrogen bonds are broken and it is back to a pulpy stage. In the wet process, fiber suspension in water is made and it is then made into sheet and dried. Paper making process is generally done on a very special machine known as Ford Rainier machine. Right, is a name. Ford Rainier means paper making machine. Stock preparation for paper making includes stock making means preparation means making suitable pulp which can be used for making paper, and I may be mixing some mechanical pulp, some chemical pulp, some semi-chemical pulp, etc. to have my proper blend of the pulp. Right, I also add sizing agent. Sizing agents are alkyl ketene dimer AKD, maybe rosin and alkyl succinic, anhydride ASA for preventing water penetration. Remember, sizing agent doesn't mean A4 size paper, A3 size paper. That is cutting the paper, to required size. Sizing agents are chemicals which prevent water penetration. Remember, in some papers, if water sprinkles and you wipe it, the paper doesn't get spoiled. In some cases, if some water is dropped on the paper becomes soggy and tears off. Right. So sizing agents are chemicals which prevent the penetration of water. Fillers such as the talc, kaolin, calcium clay, aluminum silicate, GCC, ground calcium carbonate, PCC, precipitated calcium carbonate, titanium dioxide for adding strength, smoothness, printability, brightness, oil absorption, etc., dyes for color. So these are all added in the stock preparation. So stock preparation is blending of various pulps and addition of various chemicals for various purposes. Fillers are for adding strength to the paper and sizing agents are for prevention of water penetration. So my pulp, and by beating means I mix all the chemicals and then it goes to what is known as the Jordan, which is again used for beating the pulp thoroughly, and it goes as a slurry between two wires where the sheet of paper starts forming and the moisture content is gradually coming down. These are rollers on the screen on this thing, and as the rollers go, water is squeezed and the water is recycled back and taken for other uses. Remember, paper industry is one of the major uses of water, and recycling of water is very crucial for the economy of the plant, and the water content is reduced to 80 to 82%. Then the water content is reduced to 60 to 65%. Then it goes to what is known as a dryer, which is a set of rolls, right? A steam heated roll where more water content is removed, and then it goes to a series of rollers, one after another, called calendaring rolls, right? These are, a set of rolls in a series, right? So the paper is passing through. As it passes through, the water is squeezed away, and then it starts winding up as a paper roll. You got a huge reel of paper. There's the finished paper. So the beater is the mechanically disintegrate the pulp to make paper stronger, uniform, dense, opaque, etc. It consists of metal blades attached. These are metal blades which tear the pulp and mix it thoroughly. Right. We add various agents, right? Chemicals for improving the properties of the pulp. Jordan is just a special paper making engine, right? Where thorough, beating of the pulp is done. The pulp is deformed, defibered, and dispersed, and then the pulp starts forming a web, right? to run on the endless belt at a speed of 50 minutes per minute, 50 meters per minute to 500 meters per minute, and the pulp fibers are arranged into web, and the water is drained out by gravity. Shaking motion is provided. Steam rolls are there to remove the moisture, and the calendering roll to squeeze out, and then go to the winding roll. Top 10 paper mills in India. ITC paper board. Many of the notebooks you buy in your BBC, Banastali bookshop, is ITC product. So you see the back side of the notebooks you buy, it will be clearly written. ITC was once a cigarette major, but now it is more into making biscuits, agricultural products, edible oil, and also paperboard. ITC is one of the majors. Tamil Nadu newsprint and paper, TNPL, JK paper. Most of the, what do you call the, what is that? Xerox paper and the printing paper you use, it is JK paper, the very big one. West Coast paper, Ballarpur Industry. This is by the Thapar industrialist Thapar. Andhra Pradesh paper mill, Century Textile and Industry, Seshasai paper and board, Tamil Nadu, Rainbow papers, Kanna paper. See, these plant, they have offices in, for example, Kanna paper mill, they have their office in Gurgaon, but the factories are elsewhere, right? So don't go to Gurgaon office and say, I want to see your paper plant. So you see the website, you will get, the head office and the plant location. Right? These are some of the top 10. And we have one quick video to see the paper making process. So before I say thank you, let me just put the video on place. Okay, so there we are on to the video. I am opening the video. Just confirm whether you are seeing it. Hello, are you able to see the video?
Yes, sir.
Yes, sir.
Okay. Is the audio clear?
Sir, it is not audible.
Wood chips.
Pulp solution is refined by passing it through a series of rotating and stationary blends. These give the fibers a variable degree of clean-cut or fibrillated ends. Fibrillated fibers bind more tightly with adjacent fibers, creating stronger paper. Wood fibers alone will produce rough textured and unevenly dense paper. Fillers such as calcium carbonate train tend to make the paper more opaque, give it a more controlled density. Dyes, optical brighteners, and sizes may also be blended into to improve the appearance of the paper. By far the most important process material is water. About 100 liters of fresh water are needed to make 1 kilogram of paper. Sophisticated wastewater treatment plants and closed water circulation systems on the paper market allow over 90% of this water to be recycled. The pulp solution is now a carefully controlled mix of fibers, fillers, and coloring agents suspended in water, ready to enter the paper machine.
The paper machine is the heart of the paper, a continuously running series of manufacturing processes that will convert the pulp solution into the perfect paper grade for each market application. The head box is located at the beginning of the paper machine. Here, the pulp solution is injected at high pressure directly into the space between two continuously rotating rods. These carry the pulp into the gap former, which rapidly drains the excess water from both sides. This immobilizes the pulp within milliseconds of leaving the head box, turning it into a continuous web of paper, still wet and fragile, but already exhibiting its most important sheet properties. The delicate paper is now carried into the press section by continuously looped wet felts, which carry away most of the water and stop the sheet from tearing. At the shoe press, the paper web is forced between a soft rotating roller, pressing against a hydraulically actuated metal pad. Water is squeezed out of the paper by this pressure, and this is absorbed and carried away by the wet felts. The longer section of the paper machine contains the drying circuits. These huge heated rollers dry the paper, giving it the strength to become self-supporting, ready for the processes which will determine its surface qualities. The paper sheet passes along the paper-making machine at up to 1,400 meters per minute. Every process is continuously monitored to ensure its manufacturing consistency. The paper passes through a machine calender, where two finely polished steel cylinders at a precisely determined width apart ensure that the paper thickness is consistently even. The paper then passes through a series of sizing and coating presses. Here, starch and coating colors are applied to its surface using a film press process. The coating color is sprayed onto an elastic roller, which then transfers the coating film to the paper web. Film coating creates a uniformly thick coating layer, which follows the surface of the paper. After each coating process, the surface is dried by infrared heating panels and drying circuits. Setting the surface with sizing encourages printing inks to dry on the surface of the paper, rather than be absorbed into the paper, increasing the color intensity of the finished print and improving the surface strength and water resistance of the paper. is then wound onto a series of steel cores which press against a Pope reel. This makes sure that the paper is wound at the right tension onto each core. Every hour, the paper line creates a jumbo reel containing 80 kilometers of paper sheet, 8.5 meters in width, and weighing 120 tons. The paper machine operators carefully check every aspect of the base paper quality, its thickness, opacity, and smoothness, making sure these are exactly as specified, before allowing the robot truck to carry the jumbo reel away for further treatment and finishing processes.
The final surface qualities of each batch of paper are controlled in the coating and finishing lines. For example, the paper from this jumbo reel may be sold with a gloss or matte finish, natural or bright white in color. The coating compounds are mixed according to precise recipes in tanks in the coating kitchen. The main color pigment is calcium carbonate, which makes the paper surface white. The coating solution may also include K and talcum powder. Binders can be natural starches or purely synthetic compounds, such as latex. To create a smoother surface, up to 2 more coatings per side are applied using the blade coating process. Excess solution is sprayed directly onto the paper and is then scraped off by a steel blade. Depending on the pressure of the doctor blade, a uniform paper surface is created as the irregularities in the paper are smoothed out. Each side is coated and dried in sequence to create the correct characteristics of each paper grade. The paper now has the correct base characteristics and the optimum coating consistency, but it does not yet have a perfect surface finish. This is achieved in the supercaliper. The paper passes through up to 10 rollers, which each apply pressure and temperature. These rollers have different surfaces, such as hard steel and soft rubber, depending on the type of gloss and surface treatment required. As it is wound back onto another steel core for transport, the paper in this jumbo reel now has all the characteristics needed for its end use. Apart from one final detail, its size. The jumbo reels are transported to a slitting winder. Rotary blades cut the reel into several narrow reels, which are rewound and sent forward to the finishing department. Several reels are simultaneously fed into a sheeter, which cuts the paper into sheets and stacks these onto pallets. Several printing processes, like inset, black offset, cut seal, and label presses, use paper in reel form. These reels remain uncut and are moved forward on alternating environments. Whether the paper has been cut into sheets for a sheet press or remains in the line for a web offset press, the final destination is the same: the packing lines and warehouse. Each reel of paper is wrapped in craft cardboard to avoid damage on transport. Each pallet load of sheets is either shrink wrapped or wrapped in rooms, ready for delivery to the customer. Every consignment, of both sheets and reels, is labelled with a brand name, a batch number to identify its exact manufacturing history, and its destination. All that remains is to ship the paper, now a branded, quality-controlled product with precise characteristics and performance, out to the customer.
Okay. So, hello?
Yes, sir.
Hello. Yeah, the video is over. I think you can search YouTube. Many videos of paper making are available. Get through that and check if any paper making plant is close to your place. You can have a look up for no internship there. Okay. So that is it. And thank you and wishing you all again International Day of Happiness and keep celebrating happiness. Thank you all. Thank you. Thank you. So tomorrow I am available for the lecture, not to take any new topic. We will just have a review of the various topics we have covered. Cement, chloralkali, what is that? Coal technologies, uh, chloralkali, and petroleum up down and upstream, downstream, and petrochemicals. That's it. Thank you all. Thank you.
Thank you, sir.